Welcome to this tutorial video on word2vec. For that we should know what is word2vec. Word2vec is a two-layer neural network that are used to produce word embeddings for given word corpus. Word embedding is a mapping a word into vector space. We will try with Google Colab. We will import word2vec with Gensim on Google Colab. Use the code that is shown here. Introduces Gensim's word2vec model and demonstrates its use on the Lee corpus, or for us we are trying with Google Colab. After importing, let's go on with next step. That is to import packages. Let us import packages using the above code. To see what word2vec can do, let's download a pre-trained model and play around with it. We will fetch the word2vec model trained on part of the Google News dataset, covering approximately 3 million words and phrases. Such a model can take hours to train, but since it's already available, downloading and loading it with Gensim takes minutes. Here I have fast forwarded the video and not clipping the video because I want you to know the download process in these tutorial video. This package takes lots of time to download those packages from Google Colab. A common operation is to retrieve the vocabulary of a model. That is trivial. Let's go on with next code. Here we can easily obtain vectors for terms the model is familiar with by the following code. Unfortunately, the model is unable to infer vectors for unfamiliar words. This is one limitation of word2vec. If this limitation matters to you, check out the fast text model. Moving on, word2vec supports several word similarity tasks out of the box. You can see how the similarity intuitively decreases as the words get less and less similar. Here this code will try to print the 5 most similar words to car or minivan. So as we can see, it gives the answer without any problem. As for this code, it will separate or figure out which of the below does not belong in the sequence. For next code, let's train our own model. To start, you will need some data for training the model. For the following examples, we'll use the Lee corpus. Let's go ahead and train a model on corpus. Don't worry about the training parameters, leave it for now, we'll revisit them later. The main part of the model is model.wv, where wv stands for word vectors. For the next code, it will be retrieving the vocabulary, which works the same way. From here it will be storing and loading the models. You can store/load models using the standard Gensim methods. In addition, you can load models created by the original C tool, both using its text and binary formats. From here it will be training parameters. min_count is for pruning the internal dictionary. Words that appear only once or twice in a billion word corpus are probably uninteresting typos and garbage. Workers, the last of the major parameters, is for training parallelization, to speed up training. Default value of workers equals 3. Gensim supports the same evaluation set, in exactly the same format. Now to go on with online training/resuming training. Advanced users can load a model and continue training it with more sentences and new vocabulary words. For next code, that is to check training loss computation. The computed loss is stored in the model attribute running_training_loss and can be retrieved using the function get_latest_training_loss as follows. For next it will be benchmarks. Let's run some benchmarks to see effect of the training loss computation code on training time. We'll use the Lee background corpus and text8 corpus. We now compare the training time taken for different combinations of input data and model training parameters like HS and SG. For this training, it is taking lots of time, for I have clipped the video. Here it will we now compare the training time taken for different combinations of input data and model training parameters like HS and SG. For each combination, we repeat the test several times to obtain the mean and standard deviation of the test duration. After training, adding word2vec model to DIC method to production pipeline. Suppose we still want more performance improvement in production. One good way is to cache all the similar words in a dictionary. And this code is for comparison with and without caching, and for time being let's take 4 words randomly. Now for this code let's do it with caching. And after this it will be the block of code for visualizing the word embeddings. Lastly, visualizing the word embeddings. The word embeddings made by the model can be visualized by reducing dimensionality of the words to 2 dimensions using TSNE. Visualizations can be used to notice semantic and syntactic trends in the data. Semantic, words like cat, dog, cow, etc. have a tendency to lie close by. Syntactic, words like run, running, or cut, cutting lie close together. We got the answer. Vector relations like bking and bqueen can also be noticed. Thank you for watching this tutorial video.